All right, we are starting chapter 10. I know this says 9.3, but I'm putting this in chapter 10. Okay, so chapter 10 is all about circles. I'm going to take you way back to kindergarten. Long time ago. Okay, in kindergarten, what defined a circle?
No side.
It's round. Okay, so a circle is round. Raise your hand if you think a circle has one side. Raise your hand if you think a circle has no sides. You're right. Write that down. A circle has no sides. Okay, a circle has no sides. What?
What if it has like infinite sides?
It has no sides.
And therefore it has no sides.
Correct.
Wait, but what if it has infinite sides?
Okay. All right. Fast forward. Oh, actually, I'm gonna stay in kindergarten. What makes a circle other than that it's round? Like, how do you know that this is a circle and this is not a circle? Oh, pretend it's closed. That's an oval, right? What were you gonna say? Lengths of what?
To the side, to the center.
Victor, go.
The center of it is like the same distance from the
I like that word. Put a dot in the middle of your circle. What can I call that right there?
Epicenter.
Center. Write that word down. Put a star next to it. That right there is what makes a circle a circle. Okay? Everywhere, if I go out to any part of the circle, it is the same distance. Okay? All right. Going up, you graduated kindergarten and you're going to junior high. That was fast. Junior high already. Okay. In junior high, you talked about the basics of a circle. Tell me some things. What's before that? Let's talk about what's before that. Diameter. Write that down. Diameter. What is a diameter? Someone tell me. Victor, good. Okay, from the edge of the circle through the center to the other side. Biggest thing is that it goes through the center. I'm going to color code here. The center is my blue. The diameter is my red. On your paper, you can draw arrows. So diameter goes from one side of the circle here to the other that goes through the center. That's the diameter. Kendall, what did you say? Radius. Yep. What is a radius? It is half of the diameter. So it goes from the center to the edge of the circle. So from the center to the edge, that is the radius. Now, is this the only radius of the circle? No. How many radius are there? Many, right? What about diameter? Is that the only diameter? No. There's multiple. However, are all diameters the same in a circle? Yes. Are all radius the same? Yes, because they're equidistant, okay, especially through the center. So those are three big ones. There's two more that you talked about for basics in junior high. Cool. Write that down. Circumference. Does anyone know what that means? It's like the perimeter, right? But they don't use the word perimeter because there's no sides. Okay, so the circumference is the distance around the circle. Okay, so if you started here and you ran around the circle, it's how far you went. Okay, and then what kind of goes with perimeter? Area. Yep, you talked about area of a circle. What does area mean? The inside, right? It's the amount of space that it covers. That's area. Okay, so circumference is the same word as perimeter, just for circles. Okay, this is the chapter you've all been waiting for. Drum roll. We're going to have pie. Okay, I don't want you to get scared by this. This is literally just a button in your calculator. Okay, it's going to show up in formulas throughout the chapter. Okay, but it's just a button in your calculator. Why do you think I had you star the center? Raise your hand. I heard a lot of things. Why do you think I had you star the center? Rachel.
No, I just said because.
No. Why is it important? It is the most important part of a circle. Why, Timothy? It makes it a circle. Why?
Because you can't start. Yeah.
Victor, what'd you say?
It's equidistant from the edges.
It's equidistant from the edges. This center is what creates this circle. Okay, that's why it's the most important thing. Cool. Now you can go to page 2. All right. Off to the side of your example 1, I'm going to draw it with you. I want you to draw a coordinate plane. So draw your XY axis. And then draw a circle anywhere on there. Some of you are like, you draw it first. There's my circle. Draw a circle anywhere on there. So, we are going to talk about equations of a circle today. So, I want to talk about some things. 2 most important things. Write down everything I'm writing down. 2 most important for an equation. Okay. What did we already say the most important thing is of a circle? The center. Center is one of the most important things. Draw a center point. Second most important thing, take a guess. It is the radius. Second most important thing is the radius. Okay. So here, the radius is, what's the definition of radius again? From the center to the edge. Go ahead and draw that in there. This right here is the radius. Looking at that picture there, how can I find, looking at this right now, do I know the length of that radius? No. How can I find the length of the radius? Bingo. Not Pythagorean theorem. Distance formula. So originally that would be D equals, but we're looking for R. So R equals the square root. Does anyone remember? X minus x2. I'm going to call this h, and I'll tell you why later. X minus h squared plus y minus k squared. Should have done this first, but I get that from this point on the edge of the circle is your xy coordinate. This center in a circle is always considered hk, just to keep it separate from the coordinates. Okay, so to find the distance, we are, to find the length of the radius, we're going to use the distance formula. Okay? But now we're getting to the most important part. We're going to talk about the equation of a circle, which comes from the distance formula. Highlight this, circle this, or something. Equation of a circle. This is your best friend. You just met today, but you're best friends. X minus h squared plus y minus k squared equals r squared. That is the equation of a circle. Okay, like I said, highlight, star, circle, something. It's important. Okay, how does that relate to the distance formula? It pretty much is the distance formula, right? The only thing that happened was they got rid of the square root and took the square to the other side. That's what happened. Okay, so this is the equation of a circle. Remember when I talked about the 2 most important things? Center and the radius. I'm going to put center in green. Here's my center coordinate. And here is my radius. If you have those 2 things, you can write an equation of a circle. Okay. So on your example 1, you don't have to write this. You have this on there already. X minus 2 squared plus y minus 3 squared equals 25. Right below that, I want you to write the equation of a circle. Right below. So x minus h squared plus y minus k squared equals r squared. Do you agree that these 2 equations that I have up here are very similar to each other? What I mean by that, are they in the same format? Yeah. Yes. So what the directions tell you is they want you to find the center and they want you to find the radius. So center is labeled what? HK. Let's go through that. What is in the same spot as the H? It's going to be a positive 2, and I'll explain why in a second. What's in the same spot as K? 3. So our center is 2, 3. Now the radius, I'm going to ask you this. A lot of you are going to say what? What's the radius? A lot of you are going to say the radius is 25. Is that true? Why not? Right, 25 is equal to r squared. 25 is r squared. So how do I solve that now? Take the square root of both sides. So our radius is actually 5. Exactly. Okay, I'm going to give you another example for you to try on your own. You can do it on that same spot. If I give you x plus 5 squared plus y minus 1 squared equals square root of 13. And again, you're finding the center and you're finding the radius. Center is in the form of what? HK, right? So H in our formula was here, K was here. What is my X value of my center point? What's the H? It's -5. What's my K? 1. What do you notice about the relationship from here to here? It's opposite. Yep. +5 turns to -5. -1 turns to +1. And the reason that is because in the original formula over here, okay, these are subtraction signs. Okay, so they turn opposite. Okay, so our center is that -5, 1. Now the radius. What's my radius? Is it square root of 13? No. What does square root of 13 equal? It's r squared, right? Okay, and if I come back over here, square root of 13 is in the same spot as r squared. So we have to do what to solve? Take the square root. Why did I do that to you guys? I didn't mean to put the square root there. It's a double square root. Okay, if this was just 13, we take the square root, yes? So r equals, can I simplify square root of 13? No, so it just stays. My apologies. Okay. All right, jumping right in. It says, what is the equation for a circle? In order to, and I'm going to look at this example right here. What are the two things we need to know to write an equation? We need to know the center, and we need to know the radius. So let's just start here. Do I know the center of this graph? Yeah. Right, it's right here, right? What's the coordinate for that? It is 3, 0. So we know the center. Do I know the radius?
Yeah.
I have a radius, but do I know the length of it? No. So can we write the equation right now? No, because we don't have the radius. How are we going to find the length of the radius? Okay, I heard we're going to use this point. What's this coordinate right here? Which is 1, -2. We're going to use that coordinate to help us. Center is always in the form of h, k. Coordinates are in the form of x, y. How are we going to find the length of r? Distance formula, right? Yeah. We're going to use the distance formula. So if I rewrite that here, we have the square root of x minus h squared plus y minus k squared. So let's plug in these values together. What's x? 1 minus 3 squared plus y is -2 minus 0 squared. Now we evaluate. What's 1 minus 3? -2 squared? 4 plus -2 minus 0? -2 squared is 4. What do I do with this now? 4 plus 4 is 8. Can I leave it in this form? We can simplify, right? Always simplify when you can. What's a perfect square that goes into 8? 4 and 2. And then what is the square root of 4? 2. So we have 2 square root of 2. This is nothing new, right? It's the exact same thing as when we did distance formula first semester. Okay. Now Do we have enough information to write the equation? Yes, because now we have the radius. So I'm going to take us back here. Our formula for equation of a circle is x minus h squared plus y minus k squared equals r squared. When we write the equation, are we going to have values in for x and y? No. Okay. So if I write this, we have x minus, what's h? X minus 3 squared plus y minus k is 0 squared equals, what's r? Yep, we just found it. So 2 square root of 2, what do I have to do to that? Square it also. So now, usually you have to go simplify that radius at least. So over here we have x minus 3 squared plus, what happens here? It's just y. Yep, so y squared equals, now think back to your algebra days. How do I simplify this? What does this turn into? It's going to turn into this. It's going to go 2 squared and square root of 2 squared. So that square goes to both terms inside. So what's 2 squared? 4. What happens to this? The square and the square root cancel, so I'm just left with 2. And then can I simplify one more? What's 4 times 2? 8. This is our final equation of a circle. So on these 2 examples I'm going to make up, I'm going to give you the center and I'm going to give you the radius. I want you to write the equation of the circle. Okay, so if I give you center -4, 6, and the radius of 5, and then on this one, I'm going to give you center 0, 0, and radius square root of 13. Write the equation of those 2 circles. So again, what are the 2 things you need in order to write the equation of a circle? Center and radius. Do we have both of those? Yes, we can go right into plugging in values to that equation. Center is what? Which is, that's always going to be your HK. Radius is always going to be R. Okay, so we're plugging in values. We have x minus a -4. That's how it turns into +4. See why it turns? Because of the negatives. Okay. Squared plus y minus 6 squared equals 5 squared. That's the biggest thing kids forget. Don't forget to square the radius. So then simplify. You can do all of this in one step, but since it's our first time, I'll walk through it. And then what's 5 squared? 25. This is your equation of that circle. Okay, so again, notice we talked about this at the beginning, that the center switches signs. Okay. All right. What about number 2 here? X minus 0 squared plus y minus 0 squared equals square root of 13 squared. Again, don't forget to square the radius. What is this side going to turn into? Good. X squared plus y squared equals, what happens to this? Cancel, I'm left with 13. That is my equation of that circle. Okay. Whenever you have the center at 0, 0, this is what your left side's always going to look like. Just x squared plus y squared. Okay, last example, example 3b. It's asking, determine whether each point lies on the given circle. So you don't have to draw this, but if I had this here, centers here, it wants to know that if this point for sure lies on that circle, on the edge. Okay, so it gives us a point, 6, 3. Label that your xy coordinate. Okay, what do I label the center? HK. And then your radius is 3 square root of 3. What do I label that? R. What do you think we do with all of that? We're going to plug all of it into the equation. Okay, so I'll write the equation here again. We have x minus h squared plus y minus k squared equals r squared. Plugging in values, what's x? Yep, 6 minus 2 squared plus 3 minus 4 squared equals 3 squared root of 3 all squared. Now it's just a matter of evaluating, okay? This is very similar to when we plugged in values for a squared plus b squared equals c squared. It's the same idea, okay? So 6 minus 2 is 4. 4 squared is 16. Plus 3 minus 4, negative 1 squared, 1. And then again, what happens to this thing? Distribute that. So that turns into 3 squared. Remember, it doesn't turn into 3 times 2. Still an exponent. And then I have square root of 3 squared. So what's 3 squared? 9. This cancels, so I have 9 times 3. Simplify. 16 plus 1. 17 equals 9 times 3. 27. Is that a true statement? No. So does that point lie on the circle? No. What would it look like if it did lie on the circle? It would look like 27 equals 27. That's a true statement. So that would be yes. Do you see how every problem came back to this equation? Yes? All right.